So, good day everyone. My name is Denmark Lono from BSED Math 1C, and today we're going to answer the question, what is an onto, one-to-one, and bijective function, and is it possible for a function to be both, neither onto and one-to-one, and provide some example of an onto but not one-to-one and one-to-one but not an onto function. So without any further ado, let's start. So this is our one-to-one function. So in definition, one-to-one is when every two different function or input gives two different output. So for example, let's consider this function 5x plus 2, and then we let a equals to, let's say, 4, or and b is equals to 8. So when we replace x by 4 plus 2 and 5, so if we calculate that, 5 times 4 equals to 20 plus 2, that would be 40 plus 2, and then that would be 22 and 42. So if you notice, two different input will have two different output. So that is one-to-one function. So the next one is onto function. So by definition, a function is a onto function when every element in B has at least one input from A. So for example, when we say A is equals to X, Y, and Z, and V is A to V, f of X is equals to A, f of Y is equals to V, and f of X, Z, is equals to A. So if you notice, every element in V are present here. So we can also think of it as a box, so, and a toys. If you have three boxes and you put toys inside, meaning that boxes is onto function because every boxes contains toys. So let's move on to our bijective function. So a bijective function is when a function is both one-to-one and onto. So let's consider our first example, 5x plus 2. So let's have 5x plus 2 here, 5x plus 2, and then suppose f of 2 is equals to f of let's say 4. So again, we replace that by 2 plus 2 is equals to 5 times 4 plus 2. So that would be 10 plus 2. That is 20 plus 2, and that would be 12, and 22. So again, it satisfies the one-to-one that every two different input has two different output. So now let's try the onto function. So in this one, we're going to use again the 5x plus 2. So we're going to, y is equals to 5x plus 2, and then we're going to subtract both side by 2. So that would be minus 2, and that would be y minus 2 is equals to 5x, and then we divide both side by 5. So that would be y minus 2 over 5 and x. So for any value of y, we're going to have a value for our x. So for example, y is equals to 3. So 3 minus 2 divided by 5, and that would be our x. So for any number y, there will be a value for our x. Therefore, it is an onto function. So this 5x plus 2 is a bijective function. Okay, now, so another question. Is it possible for a function to be neither onto or one-to-one? So, for me, my answer would be yes. Why? Consider this function x squared. So, we're going to have negative 5 and 5, and that these two are two different input. So in order to become an one-to-one, this should have different output. So let's say x squared, so that would be negative 5 squared and 5 squared, so that would be 25 and 25. So therefore, this is not an onto function, or this is not one-to-one function, because two different input has the same output. So now let's check for onto function. So if you notice, x squared produces only positive number for any real number. So that means the negative numbers are left out. So when defined r to r, so the negative numbers are left out. So therefore, it is only caters the positive numbers. Therefore, it is not an onto function. So this one is x squared is neither onto and one-to-one. Now let's talk about one-to-one function but not an onto function. So from this one, element of a real numbers to real numbers, 1, 2, 3, and 4, 5, 6, 7, where f of 1 is equals to 4, f of 2 is equals to 5, and f of 3 is equals to 6. If you notice, different input has different output. So the 1 is equals to 4, f of 2 is equals to 5, and f of 3 is equals to 6. So therefore, it is an one-to-one function. But this is not an onto function, because if you notice, 7 are left out. So in definition of an onto function, for every element of B, there should be at least one element in A. So therefore, this is not an onto function, but this is a one-to-one function only. So now, is it possible for an function to be onto but not one-to-one? So again, that is also possible. Let's just go back to our previous example, this one. So this is an onto function, but this is definitely not a one-to-one function, because if you notice, f of x and f of g has different input but the same output, which is the letter a. So therefore, this function is not an one-to-one function but only a onto function.